Hello everyone and welcome. In this session, I will be teaching hydraulic efficient channel sections. So let's start. Hydraulic efficient channel sections. A channel is said to be hydraulic hydraulically efficient when the first criteria is for a given discharge for a given discharge denoted by capital Q, its its construction cost is minimum, and the second criteria is for a given for a given cross-sectional area, the discharge carrying capacity is maximum. Now we know that Manning's formula, from Manning's formula, I can write discharge capital Q is equal to 1 upon m a r to the power of 2 by 3 and s to the power of 1 by 2, where n is the Manning's roughness coefficient, a is the wetted area, r is the hydraulic radius, and s is the slope. So I can write hydraulic radius, hydraulic radius r is equal to A upon P, where A is the wetted area and P is wetted perimeter. Wetted perimeter. So I can write, so I can write Q is equal to 1 upon N A upon P to the power of 2 by 3 S to the power of 1 by 2. So Q is equal to 1 upon N A to the power of 5 by 3 upon P to the power of 2 by 3 S to the power of 1 by 2. So I can write Q is directly proportional to 1 upon P to the power of 2 by 3 because all N, A and S are constants. So from here I can write for a maximum discharge and for a given for a given cross-sectional area, perimeter P should be minimum. Now let's start with most efficient rectangular section. Most efficient rectangular section. Let's draw a rectangular section first. Here, y is equal to depth of flow and b is equal to width of flow. So I can write wetted area capital A is equal to B into Y, and perimeter P is equal to B plus 2Y. From here I can write B is equal to A upon Y. So let's put this B here so that I can get P is equal to A upon Y plus 2Y. So as we know that for for most efficient rectangular section, rectangular section, P should be P should be minimum. So I can write dP upon dy should be equal to 0. So again, I can write dP upon dy is equal to minus A upon y square plus 2, and minus A upon y square plus 2, this should be equal to 0. So minus A upon y square is equal to minus 2. So I can write A is equal to 2y square, and A is nothing but B into y is equal to 2y square. So y is equal to B upon 2, or I can write B is equal to 2y. This is one of the condition for rectangular section to be most efficient. Another thing, let's find out the hydraulic radius. So hydraulic radius denoted by capital R is equal to A upon P. So I can write R is equal to B into Y plus B plus 2Y. So I can write R is equal to B into Y divided by B plus 2Y is nothing but B, since B is equal to 2Y. So R is equal to B into Y divided by 2B. We can cancel out B and B. So R is equal to Y by 2. So from these two conditions, I can write for most efficient rectangular section, y should be equal to p by 2, and the second one is r should be equal to y by 2. Now let's take another section, that is the triangular section. So for most efficient triangular section, let's take another example of a triangular section. So let me draw first a triangular section. So here T is top width. T is the top width. Y is again depth of flow, depth of flow, and the side slope for this triangular section is 1 is to m, that is for 1 vertical, it's m horizontal, and theta is the half of the apex angle. So from this figure, I can write down, capital T, sorry, okay, let's write here. Capital T is equal to, this distance will be equal to my. So capital T is equal to 2my, and area will be equal to half into capital T into y. This is will this will be equal to half into 2my into y. So let's cancel out 2 and 2. So A is equal to my square. From here I can write y is equal to under root A upon m. Again, perimeter P is equal to, this will be equal to 2y under root m square plus 1. And for most efficient triangular section, this P should be minimum. So I can write dP upon dm should be equal to 0. Again, P is equal to 2y under root m square plus 1. I can write 2 under root A upon m under root m square plus 1. So P is equal to, 2 under root A, again I'm under root m square plus 1 upon m. P is equal to 2 under root A m plus 1 by m. Squaring both sides, I can write P square is equal to 4a m plus 1 upon m. Now dP by dm should be equal to 0. So the left hand side will become 2p dP upon dm should be equal to t upon dm of 4a m plus 1 by m. So this becomes 0. So 0 is equal to d upon dm of 4a m plus 1 by m. 0 is equal to this 4 and a here. A is equal to constant. So I can take it out from the bracket. So 0 is equal to 4a d upon dm of m plus 1 by m. So I can write 0 is equal to, if I will send this one to the set, it will become 0 only. So I can write 0 is equal to d by dm of m is 1 plus 1 by m is minus 1 upon m square. So I can write 1 by m square is equal to 1. m is equal to 1. So that means when m is equal to 1, that means we have the side slope 1 vertical is to 1 horizontal. That means I can write this will become our theta. So tan theta is equal to 1 upon m 1. So theta is equal to 45 degree. So a channel to be most efficient triangular section, triangular section, this theta should be equal to 45 degree. If this is theta, then this is also a theta, which should be equal to 45 degrees. So our apex angle should be a right angled triangle. So m is equal to 1 is the most favorable condition here. So I can write area is equal to my square, which will be equal to y square only, and p is equal to 2y under root m square plus 1. Here m is equal to 1, so our p will become 2y under root 2. I can write p is equal to 2 under root 2y. Also, let's calculate the hydraulic radius. Hydraulic radius r is equal to a upon p, which will be equal to y square upon 2 under root 2y. Let's cancel out y and y. So r will be equal to y upon 2 under root 2. So area is equal to y square in case of efficient triangular section, and p is equal to 2 under root 2y. These are the three conditions for a triangular section to be most efficient. Thank you.